This is where baseball is played, and whether you realize it or not, also where physics takes place. Baseball is played on a diamond-shaped field where the objective is to hit the ball and get runners around all the bases to score. One team plays in the field and they try to get 3 outs before the other team scores, and then it's their turn to hit. There are a total of 9 innings, and whoever scores the most runs by the end of the 9 innings wins. The game is always first started with a pitch, and the batter swings to hit the ball. If the pitcher throws 3 strikes, the batter is out. But if the pitcher throws 4 balls, which are pitches outside the strike zone, the batter walks to first base. The batter also gets to walk to first base if they are hit by a pitch. The batter can also get out by hitting a ground ball and having the fielder throw it to first base before the batter gets there. You also get out when the fielder catches the ball in the air. Hitting a baseball seems simple, but it really takes a lot of science to make it happen. To hit a baseball far, you need to have a lot of force. Force is the strength or energy as an attribute of physical action or movement. This is an example of my brother Brady exerting force onto my younger brother Dylan. To have lots of force, you need high acceleration and lots of mass. Say this person weighs 80 kilograms and swings the bat at 5 meters per second. If he makes contact with the ball perfectly, he will put 400 newtons of force into the ball. This is how you would use the force equals mass times acceleration formula to find the solution to the equation. No matter how hard you hit a baseball, it will always come down. This is due to the effect of gravity. Gravity is the force that pulls everything towards the center of the earth.
Gravity!
Another force that always acts on the baseball is drag. Drag is the force of an object that resists its motion through a fluid. In this case, the fluid the ball is traveling through is air, and the air is resisting the ball. Even though that throw was very far, it would have traveled even further if the air was not resisting the ball's travel. Another example of drag in baseball is as soon as the ball leaves the pitcher's hand, the air begins to slow the ball's acceleration down. This gives the batter a better chance to hit the ball, but when the batter makes contact, the ball also begins to be slowed down by the air when it's traveling in the opposite direction, forcing it to not travel as far. Pitchers have a huge advantage over batters because they can control the ball by throwing different types of pitches, such as curveballs, fastballs, knuckleballs, changeups, splitters, and more. Each pitch is thrown differently, and the ball will move differently with each pitch. Thanks to the Magnus force, a ball will travel in different directions due to its rotation. The Magnus force comes into play as a spinning ball moves through the air. It spins a boundary layer of air that clings to its surface as it travels along. On one side of the ball, the boundary layer of air collides with air passing by. The collision causes the air to decelerate, creating a high-pressure area. On the opposing side, the boundary layer is moving in the same direction as the air passing by, so there is no collision and the air collectively moves faster. This sets up a low-pressure area. The pressure differential, high on one side and low on the other, creates a lift force, otherwise known as the Magnus force, that causes the ball to move in the direction of the pressure differential. A baseball has seams, which allows players to easily grip and apply unique spin and rotation to the ball if they choose to. Most field players hold the ball in a force seam, so it won't tail off on them when they throw it. On the other hand, the best pitchers can hold the ball like this, and it makes it very difficult for batters to make contact. The best pitch for a batter to hit is a straight fastball. Although it can be hard to time your swing that quickly, you don't have to worry about the ball curving. The faster a ball's velocity is when it's pitched, the further the ball will go when you hit it. Say that pitch was thrown 70 feet in 3/5 of a second. Since velocity equals distance over time, that would be 70 divided by 3/5, which equals 116.66 feet per second, which is 79 miles per hour. This is how you solve to get that solution. Velocity is defined as the speed of something in a given direction. When swinging level, the batter has a better chance of hitting high velocity pitches. Notice how the batter does not try to hit the ball upwards, but more of a line drive. When a good batter notices a pitcher pitches with slower velocity, they have more time to judge the pitch and swing at a different uppercut-like angle to hit it further. This is how you swing when you're trying to hit a home run. The reason batters swing like this to hit home runs is because they can send the ball higher up into the air. Another huge emphasis of hitting a ball well is the moment of inertia. Inertia is a measure of how difficult it is to change the velocity of an object by applying a force, and is usually expressed in terms of mass. The greater the inertia of an object is, which basically means the more mass an object has, the more difficult it is to change its velocity. We can calculate the inertia, and this will tell us how effective the collision was. We can track the displacement the ball travels after it's been pitched. This may not always be the same as the distance traveled, because when the batter hits the ball past the pitcher, it subtracts the distance it took from the pitch to get to the plate. This image reveals the distinct difference between displacement and distance. As you can see, the displacement is just the change in position. Displacement is defined as a vector quantity that refers to how far out of place an object is. It is the object's overall change in position. From where I am standing on the pitcher's mound to where my brother is standing in the outfield is the displacement of the ball I hit. The distance would equal the picture of my brother in the outfield plus the new picture of my other brother standing at home plate. Displacement's formula is the initial velocity times the time added to 1/2 the acceleration multiplied by the time squared. Momentum is mass in motion, so basically any object that is moving has momentum. When a baseball is moving, its momentum is conserved. The conservation of momentum formula proves that the energy is conserved during the process. M1 stands for the mass of the ball. V1b stands for the velocity of the ball before the collision. M2 stands for the mass of the bat. V2b stands for the velocity of the bat before the collision. V1a stands for the velocity of the ball after collision. Another aspect of baseball is stealing. When you steal, you slide to avoid being tagged. When you slide, you slow down to a stop due to friction. Friction is defined as the resistance that one surface or object encounters when moving over another. When watching baseball, you will often hear coaches yelling at players to not get underneath the ball. When a player gets underneath the ball, you create backspin, and this causes the ball to go straight up and not far at all. The backwards rotation gives the ball more airtime and sends it straight up. It's very similar to the backspin on a basketball's shot. The opposite happens when you get on top of the ball, or hit a ground ball. Now the rotations are forward and force the ball to plummet towards the ground rapidly, rolling or bouncing along the dirt and grass. A perfect hit is when you squarely hit the ball in the sweet spot of the bat, which is about 6 inches from the end of the bat.
This is the sweet spot of the baseball bat.
At this point, there is a maximum opportunity for the energy to be transferred and for the ball to travel far. Energy is the property that must be transferred to an object in order to perform work. As the batter is in their stance, waiting to hit, all of their energy is stored in his potential energy. As the batter begins their swing, the potential energy is converted into kinetic energy, which is energy in motion or movement. Putting the conserved force of the potential energy into action transfers the energy from the bat to the ball and sends the ball flying through the air. If you have a better understanding of the physics in baseball, you will become a better player. Adapting to the spin of the ball as a batter is vital to having success hitting. I hope you feel greater informed on the physics of baseball to apply to the real world.